Hi everyone, this is a water damage repair of a MacBook Air A1466 from 2015. There are several areas which are severely water damaged. I'm starting here with removing the overfill over the capacitors to make room for the chip which I'm replacing later. I'm using the quick at 500 Celsius and maximum airflow which is 120. The stuff is pretty soft and can be removed easily within some seconds. In the next step I'm applying flux to help solder flow and absorb any residual corrosion which is left on the board and on the joints at the components. I now have removed the chip, and in the next step I'm applying leaded solder to lower the melting point of the solder which is on the board or comes from the factory, which is obviously unleaded. It makes wicking easier in the next step so you won't rip any pads. I am using Goodwick and MTech NC559 V2TF flux and some generic leaded solder. I don't remember the name exactly. After wicking, I'm cleaning the board with some PCB cleaner. The PCB cleaner is called Cleanser and comes from Poland, which is, in my eyes, the best PCB cleaner on the market. So I'm making sure to clean every corrosion or left flux from the pads to have clean joints in the next step. I'm also using a sculpture blade here to remove leftover solder or corrosion to make the pads even cleaner. I'm applying flux again, which isn't really necessary on drag soldering. But as you can see on some joints, it wasn't, like on this one, it wasn't really enough flux. So the solder is making some spikes. And I'm also, just for perfection, adding solder to the pads which are not necessary to apply solder to. And I'm removing the solder which I accidentally dragged onto the coil. Here you see the donor board I'm taking the chip from. And again I'm using 500 Celsius at maximum wind speed. Now I'm transferring the chip to the board with the water damage, getting it in position and holding it first with the tweezers, have it settled in place by its own, so surface tension will do the trick. After that is done, I'm letting the solder harden. Then I'm pressing again down on the chip to have the chip really flat on the board. And I am again applying flux to remove any solder that is too much on the pads or on the connections. After the chip is soldered, I am cleaning with PCB cleaner, a brush and a clean room wipe to absorb any flux or other residues from the board. The brush is actually a flux brush, which is used for BGA work, and the bristles were pretty long, so it wouldn't clean that good. And I cut half of the bristles off to have them more stiff, so they are better for cleaning here. And as you can see here, there are much more components and areas affected by the liquid damage. And as before, I'm applying flux, removing the chip with hot air at 500 Celsius at maximum wind speed. The MacBook boards are pretty thick, so you need temperature and wind speed. Same procedure as before. Applying leaded solder, wicking away the mixture so I don't have any left corrosion on the pads to guarantee clean joints. Once again cleaning, absorbing. I really have to clean very well in the first place because I don't have a UC. putting on some flux, adding leaded solder, and next step is taking the chip from the donor board and placing it on this one. And as you saw, the chip moved right into place. I just gave it a little tap. Once again, cleaning the area and surroundings with PCB cleaner and a clean room wipe.
Ich habe leider keine passenden Einträge.
And I'm using a toothbrush as well to have a even better cleaning effect, because I wasn't happy of how it looked. So you will see there is much or not that much of residue on the board as you saw before. There are some capacitors which I'm cleaning here, but you saw the corrosion was only on the sides and not that much on the pins itself. So in my eyes, cleaning with a toothbrush is good enough to ensure there will be no problems in the future. And I'm trying to get rid of the discolorations around the caps as well, to give it a, well, it's just for optical reasons, to make them look better. Now I'm focusing on the next corroded area. This is the JTAG connector, which has no purpose in terms of functionality of the MacBook, so it can be removed and you won't have any disadvantages from it. I'm again applying flux and hot air to remove the connector completely. After removal, I just took a clean room wipe again and some PCB cleaner to see the burned area where the pad is missing exactly. I'm scraping the area to see if there are any layers connecting to each other and possibly short out some circuits, which was not the case here, and the missing pad won't do any harm. Here I am again applying flux to easily remove the solder from the pads using the solder wick. And you don't have to be extra careful here, because these pads don't have to be saved, as I don't plan to use them. I'm cleaning again using a wipe and some contact cleaner. After the whole board repair, I'm masking the area of the JTAG with some silicone, like the overfill you saw at the beginning of the video, because this is a very common area for water to enter the board, so the pads are protected. I'm just cleaning the board once more, making sure there are no water markings or corrosion left on the board. So I'm turning the board over and finally continue on the other side. And this is the SMC area where I spotted some corroded resistor. In this very delicate area, you will see me applying some aluminum tape to protect the SMC from overheating. Yeah, this is the foil I just cut to apply it over the SMC so it won't get any overheating damage. First I'm cleaning with some PCB cleaner and the brush to see if there's anything left from the resistor or maybe some missing pads already, but none of that was the case. So I'm applying flux and I'm removing this IC as well. You could remove the resistor by using only your soldering iron, but the tip I installed was pretty big, so I don't felt like messing around in that very crowded area, knocking off some other resistors which I had to replace later, and just to save me from doing any additional work which shouldn't be necessary. So I'm cleaning again the pads which were corroded, so I don't solder on top of any corrosion. And as the pads of the resistor are very tiny, I didn't see the need to mix the solder. I'm just wicking it away as it was. And I'm, as I did at the beginning, also putting the solder back which was on these points. Here is the donor board where I'm sourcing that resistor from to replace it on the board which I am working on. And you can see me again finally shaping the pads to make them look factory and replace some solder missing on the resistor which got lost by wicking in the middle. And as I was finally happy with the look, I removed the aluminum tape which had some nasty glue which I am now removing to clean the board. And I'm using my old toothbrush here to clean the whole area from any glue or flux or corrosion which was left in that area. And as this area looks pretty clean, I'm just checking again for any corrosion in any parts of the board. Like you see here, I found another IC with corroded pins, so I applied flux and some hot air. So this one has to go as well. And I found this ugly looking cap and removed it as well. Same procedure as before. Applying flux, mixing solder, wicking the solder away, applying new. And I'm basically trying to apply the lowest amount of solder on this center pad, because when I'm pressing down on the chip, it doesn't shoot out that much solder, which can lead to some shorts on the pins. So as my replacement chip on the donor board looks worse than the other one I just took off, I'm replacing the capacitor first. I think what I'm doing now, if I remember correctly, I'm cleaning the board once again, and I am taking a look at the chip I previously removed from this board. Take a look under it, and the chip wasn't that bad corroded. So I rather take the chip I removed from this board than taking the other one, which looked pretty bad, from the donor board. And the corrosion wasn't that bad on this chip right here. So I decided to reuse the chip by just cleaning the pads. So same procedure as the one I did at the beginning. Applying hot air, have it float into place by its own. Wait till the solder hardens, press down on the chip, apply hot air again to make a proper connection, and have the chip sit flat on the board. Now I am applying flux again to clean any excess solder from the chip. Once again I am using the brush to clean any residual flux from the board. And you see it's looking pretty clean already. So the clean room wipes, as you can see, really give it a like factory finish. So here's the next corroded area, which caught my attention. Oh, here is a corroded probe point which can cause some loss of signal or missing voltages, so you should really take care of the probe points. Here's another probe point, which is, or is it a pad? It's a pad where, not connected pad, but it seems to sit between some vias. So I'm cleaning the joints here as well, but the corrosion wasn't that bad. And the joints were intact, so it was just sitting on top of the joint. So here you see a corroded pad which sits between two resistors, which I am scraping now to see if there A is any pad or B the connection is intact. And as the copper was showing after scraping, the connection seems to be okay. So here you see a bit more corrosion on top of this chip, which I am removing now using the soft brush or softer brush. And I use the toothbrush as well to clean the rest of the corrosion which still sits on top. I'm finally switching to the tweezers, and the corrosion was only sticking to the logic board itself. So I removed it by scraping with the tweezers. Then I tilted the board a bit and tried to get a look under, and the image on the camera which you see here isn't the same as I see it under the microscope. The camera itself sees less than I do while looking through the microscope. So as I'm pretty happy with removing all the corrosion from the board, replacing everything necessary, I didn't measure anything. I thought it was time to finally plug that board into the MagSafe adapter using a DC power supply. And you can see there is no light on the charger. No light, and I wondered after all this work why the light didn't appear. As you saw, there was a short blink of a green light on the charger, so I thought maybe the connector is dirty, and it turned out the connector was in the end. So the proper cleaning procedure was applied using a brush and some PCB cleaner, wiping it dry with a clean room wipe. Yeah, now it's okay. Now it's as clean as it gets. So I'm connecting the MagSafe once again, and you should have seen it. There was a green light, it turned to an orange light, and the fan was spinning. So thanks for watching, and for anyone who may was a bit skeptical, here is the final video from my capture software to my bench, the board with the rusty coil, to the orange light and DC power supply. Thank you all for watching.